Okay, for this next problem, we're going to use what's called the combined gas law. And here's the version of this gas law that I like. P1 times V1 times T2 is equal to P2 V2 times T1. And these ones and twos are just you can think of them as the gas at different times. And so at some time, it had a volume of 545 milliliters and a temperature of 35 degrees C. At some other time, the temperature was raised to 151 degrees C. And so to work these kind of problems, what I do is I go and I list out my variables, and then I go in and see what we have and what we need. Okay, and so I go into the problem, and the first thing I had is this volume, 545 milliliters. And so I'll make that my first volume, and 35 degrees C. And the milliliters are okay. I could change that to liters or leave it as milliliters, but the temperature must be in Kelvin. So I'm going to do 35 plus 273. So this is 308 Kelvin. And then it asks me, what is the final volume? And so I know that's going to be my unknown. And then what's that final volume at this other temperature? 151 plus 273 gives me 242 Kelvin. And it says at constant pressure. So P2 and P1 are equal to each other. And in effect, what that allows me to do is drop the pressure out of the equality. Since it's the same on each side, it could be 1, it could be 15, it could be 1,000,000, but I know that it's the same, and so a constant I can withdraw from both sides, and that drastically simplifies my equation. So I'm solving for V2. V2 is equal to V1 times T2 over T1. Okay, and so this is a container that can expand and contract, so this could be a balloon, and this is saying what will happen if I move the balloon from a colder room to a significantly hotter room, and the balloon will expand.